Alright guys, it's Mr. Meehan here. Today we're going over Unit 1, Lesson 2. It says, I can use the midpoint formula to find the midpoint of a segment, and I can use the distance formula to find the length of a segment. So we're going to be talking about the midpoint formula and the distance formula today. So definition, it says a blank of a segment is the point that divides the segment into two congruent segments. This is called the midpoint. Alright, the midpoint of a segment is the point that divides the segment into two congruent segments. So some review here. It says, given the coordinate plane with points P and Q, do you remember how to find the coordinate of point P on the coordinate plane? Hopefully you do. Hopefully you can notice that the coordinate of point P is -3, it looks like, in the x value, and then -4 in the y values. Okay? So the coordinate for point P is -3, -4. What is the coordinate of point Q? Well, hopefully you remember how to do this too. Looks like we got 1 for the x value and 2 for the y values, okay? Now what if we look at number 3 here and it says, what is the midpoint of PQ? All right? What if we wanted to figure out what the midpoint was between P and Q? And remember, the midpoint is the point that divides the segment into two congruent segments. So it's like the very center, which cuts it in half, basically. So if you wanted to figure that out, up until now, you would probably just take a guess, right? So what's the midpoint of PQ? Well, you would go, oh man, that looks maybe about the center, right? And that would mean this segment is congruent to this segment. And remember, the hash marks mean congruent. And we could say that that midpoint is probably like -1, -1, right? So let's say the midpoint of PQ is -1, -1. And then in this scenario, I think that's correct. But how often are you going to be able to guess correctly? Not very often. So that's why we have the midpoint formula. So every time you're trying to find the midpoint between 2 points or on a segment, right, you're always going to use the midpoint formula. So the midpoint formula says the midpoint between any 2 points on a coordinate plane is x1 plus x2 divided by 2. That's the first coordinate, like that's the x coordinate of the midpoint. And then y1 plus y2 divided by 2. All right, that's the midpoint formula. So whenever you're trying to find the midpoint of a segment or 2 points that create a segment, all you do is plug the points into this formula, and then you get the midpoint of that line, right? So here the coordinates of point 1 are x1, y1, and the coordinates of point 2 are x2, y2, and you plug those in. So this will make more sense here when we do this example. It says find the midpoint of AB. I'm going to rewrite the midpoint formula so we can see it down here. So x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. All right. So what I want to do here is write down the coordinates of A and B, just so we have them. So what's the coordinate of point A? It looks like that is -3, comma 2. And the coordinate of point B is 4, comma -3. Okay? So what we do here is we're going to label each one of these points, or we're going to label one of these points point 1 and one of these points point 2. It does not matter which one's point 1 and which one's point 2. The order of 1 and 2, it does not matter. Okay? So I'm just going to say A is point 1 and B is point 2. All right? Just for easy reference. So here, all we're going to do now is say that x1 is the x value of point 1, which is -3, plus x2, which is the x value of point 2, which is 4, and then divide that by 2. So I'm just plugging these points into our midpoint formula here. All right, so then if we want to do the y values here, we do the y value of point 1, which is 2, plus the y value of point 2, which is -3, and then divide that by 2, and then we just simplify. So -3 plus 4 is +1, so we get 1 over 2, which is 1/2, and then 2 plus -3 is -1, divided by 2 is -1/2. So what's the midpoint of AB? Well, it's 1/2 -1/2, and if we wanted to graph that, it's about right there. And doesn't that look like it's about the midpoint, right? Making these two segments congruent. All right, next example here. It says find the midpoint of each segment given the endpoints. Number 1 here, it says -2, 5 and 8, -12. I'm going to say that this is point 1 and this is point 2. Remember, it doesn't matter which point is point 1 or point 2. I could make this one point 1 if I wanted to, or this one point 2. It really doesn't matter. I'll actually leave it like that for now. So, our midpoint formula again, I'll write it down a third time here just for reference. x1 plus x2 divided by 2, y1 plus y2 divided by 2. Alright, so there we have, let's see, x1 would be 8, so that's the x value of 0.1, plus x2 is going to be negative 2 divided by 2, comma 5 plus negative 12, it looks like. Or actually, sorry, y1 would be negative 12, wouldn't it? Plus y2, which is 5, and divide by 2 like that. But again, even if I wrote 5 plus negative 12, the order doesn't matter. I would still get the same answer. So while I am being specific, the order really doesn't matter. So we're going to get 8 plus negative 2 is 6 over 2. Looks like, yep. And then negative 12 plus 5 is going to be negative 7 over 2. We can simplify that real quick and say that is 3 comma negative 7 over 2. So that's the midpoint of those two coordinates. So we just found the midpoints of 2 points, even though we didn't even have the coordinate plane, right? They just gave us 2 random points, and they said find the midpoint, and we did it. Let's see if we can do it again. So I'm going to make this point 1 this time and this point 2. Let's say now we have x1 is 3 plus x2 is negative 6 divided by 2. Then we have negative 7 plus negative 4 divided by 2. And then we could say 3 plus negative 6 is negative 3 over 2. Negative 7 plus negative 4 is negative 11 divided by 2. And that's really our final answer. I would not simplify that in any way, personally. I would just leave it like that. So that's the midpoint between those two coordinates. This next example here is super important. This is a very important type of problem, but it's kind of tricky for people if you haven't seen it before. So it says, given the midpoint of line AB is M, where M is 2, 3, and one endpoint of the same line is A, 4, 6, find the other endpoint of the line. And the other endpoint of this line would be B, right? If we had a line here, we have point A, where A is 4, 6. We have point M, where M is 2, 3. And then we have point B, and we're saying that M is the midpoint, so those two half segments are congruent. We got to figure out what point B is, okay? So how to set this up, what we're going to do is what I would do, and I think this is the best way to do this, is to write out the midpoint formula again, so you have it down in your brain and you have it memorized. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. And what we do here is we set this whole thing equal to the midpoint that they gave us. And they gave us the midpoint M as 2, 3. Okay? So that entire midpoint formula is going to equal 2, 3 because the midpoint that they gave us is 2, 3. Now they gave us one endpoint here that we can use, and let's just say this endpoint is going to be endpoint number 1 and B can be endpoint number 2. So what we can do now is erase the x1 and the y1 and plug in our coordinates for point 1 or A, right, which would be 4 plus x2, and then it would be 6 plus y2, and those would both be divided by 2. All right, and then we just kind of solve this. So what you notice is that 4 plus x2 divided by 2 is going to equal 2. And then 6 plus y2 divided by 2 is going to equal 3. And so you just set those equal to each other. So you can say 4 plus x2 divided by 2 equals 2. And 6 plus y2 divided by 2 equals 3. And we just solve for those variables, right? We can say 4 plus x2 equals 4. x2 equals 0, and then 6 plus y2 equals 3. Nope, it does not. 6 plus y2 equals 6, y2 equals 0. So what it's telling us is that point B is going to be 0, 0. The x2 is 0, the y2 is 0. So that's our endpoint, point B. All right, this next problem here, we're now talking about distance. So kind of changing the subject a little bit. It says, how can we find the distance between point P, where P is x1, comma y1, and point Q, where Q is x2, comma y2 on the coordinate plane? Remember the Pythagorean theorem, it says. That's the hint. So what I'm going to do is I'm going to write in point P as x1, comma y1, I think it told us. Yep. Comma y1. And point Q is x2, comma y2. And here's what we're going to do, okay? We have this ambiguous coordinate plane with no coordinates on it. And we know the coordinate of point P is x1, comma y1. We know the coordinate of point Q is x2, comma y2. And what I want to do is draw a line from point P over to point Q, kind of like this, on the x's, right? So we're drawing a line from x1 to x2, basically. If x1 is right here, then x2 would be right here. Okay? Let's do another line up and down here. And this, since we're going up and down, would be the y value. So now we're going from y1, okay, to y2. Okay? Now what can we do? Well, we can find the lengths of those sides pretty easily. We can say that the length of the red side is now x2 minus x1, okay? And then we can say the length of the green side is now y2 minus y1, all right? Then, what if we wanted to find the length of this larger side? We could say it's the hypotenuse, right? We could just say that this is a right triangle, and the light blue question mark is the hypotenuse side, okay? How can we figure that out? Well, the Pythagorean theorem. Remember it said use the Pythagorean theorem. What is the Pythagorean theorem? Well, it is a squared plus b squared equals c squared. What's a squared and b squared in this scenario? That's our red and green side, and then c squared is going to be our blue side. So actually I'll write it in the colors that we have respectfully. So a squared plus b squared equals c squared. So let's just plug in the kind of lengths that we have right now. We have a squared as x, I'm going to do it all in dark blue now, x2 minus x1, and that's squared, plus b squared, which is y2 minus y1 squared, and we're setting that equal to c squared, all right? Because that's what we're trying to figure out. We're trying to figure out the length of Mr. Light Blue there, all right? And Pythagorean theorem, if red is A, green is B, and light blue is C. If we're trying to figure out what C is, we take the square root of both sides. So we can say x squared minus x1 squared plus y2 minus y1 squared equals C. The square root of C squared equals C, right? So the length of C is, let's highlight it in the appropriate color, that funky formula right there. So what we just derived is the distance formula. And that's what we can write down right here. What I want you to write is the distance formula, x2, how do we write it up there? Yep, x2 minus x1 squared plus y2 minus y1 squared. So every single time they give you two coordinates on a coordinate plane, just like you plugged them into the midpoint formula when you're finding the midpoint, you plug them in here the same way with the point 1 and point 2 to find the distance between those 2 points. All right, so let's do some examples. So this example 1 here, it says, if a pitcher throws a ball to the batter, what is the distance the ball travels? So we're going from the batter to the pitcher, basically from 0, 0 to, it looks like 6, 5. So let's write those points down. We're going from 0, 0. Actually, we're going from 6, 5 first, right? We're going from the pitcher to the batter, right? So 6, 5, and then 0, 0. Let's just say that 6, 5 is point 1, and this is point 2. And all we're going to do is plug these into our distance formula, and we're going to keep that right above us so we remember it. So write our giant square root here, and just plug in the points, man. Plug and chug. That's what I say. Plug and chug. All right. So what's going to be x2 here? Well, that's the x value of the second point. That's going to be 0 minus the x value of the first point, which is going to be 6, plus the y value of the second point, which is 0, minus the y value of the first point, which is 5. So what we're going to get here is negative 6 squared plus negative 5 squared. What's negative 6 squared? Well, that's 36. What's negative 5 squared? That's 25. And then what's 25 plus 36? Is that 61, I believe? So the square root of 61 would be your answer. And me personally, I don't know about other teachers, but me personally, I would just leave it like that. I don't want you to simplify it. I don't want you to plug it in your calculator. If it's not a perfect square, then don't find the square root of it. I think that's your final answer. So if the pitcher throws the ball to the batter, what is the distance the ball travels? It travels the square root of 61 feet, I guess we'll call it. They want us to convert it down here. I'm not going to do that. We're just going to call it feet. All right. All right, so this next example here, it says if the batter hits the ball to the shortstop, what is the distance the ball travels? Let's pick a good color here. Let's pick orange. We're going from the batter to the shortstop. So let's write down the coordinates here. We have the batter at 0, 0, and the shortstop looks like he's at 5, 10. So if we want to find the distance between those 2 points, we plug it into the distance formula. Let's make 0, 0, 0.1 and 5, 10, 0.2. Again, it doesn't matter which point's 0.1 and which one's 0.2 as long as you're consistent with it throughout the problem. Just like with the midpoint formula, 0.1 and 0.2 don't necessarily matter. It's just as long as you just have to be consistent with it throughout the whole entire problem, okay? So we're going to do x2 minus x1, so 5 minus 0 squared, plus 10, so y2 minus y1, 10 minus 0 squared. That looks like it's going to be the square root of, let's see, 5 squared plus 10 squared. 5 squared is 25, and 10 squared is 100. So you're going to get the square root of 125. Let's say it's feet. There we go. And again, I would just leave it like that. If it's not like a perfect square, then don't take the square root, okay? So the square root of 125 feet from the batter to the shortstop. One more last example. It says if the shortstop throws the ball to first base, what is the distance the ball travels? All right, so let's say light blue now. We're going from the shortstop to the first base. The shortstop is at 5'10". The batter, and we're going to say that's 0.1. I'll use a different color. 0.1. And then first base is at 10, 0, it looks like, and we can call that 0.2. 10, 0. That can be 0.2. And again, we just kind of plug and chug into our distance formula. So we're going to get x2 minus x1, which is 10 minus 5 squared, plus y2 minus y1, which is 0 minus 10 squared. Looks like that's going to be negative 5 squared, plus 0 minus 10 is negative 10 squared. So that's going to be negative 5 squared is really 25, and negative 10 squared is really 100. So we're going to get the square root of 125 again, and we're going to say that's feet. So that's how you use the distance formula.